AP Statistics Chapter 1 Practice Test. The name of the unit is Exploring Data. So we'll talk about like all the different tables and also box plot and dot plot and also free response and multiple choice. Okay. All right. So let's start it. Number 1. You measure the age, marital status, and earned income of SRS of 1,463 women. The number and type of variables you have measured is what? Okay. This is a simple random sample. So SRS stands for simple random sample. If you look at each category here, so the age is basically quantitative data. Marital status is a yes or no, so that's a categorical. Married or unmarried, so it's a categorical. And on the income is the numbers, right? How much money they make in a year, so that's a quantitative. So as you see, you have a it said the number of variables, so you have a 3, so not 4. A doesn't make sense. And then this one is 1 categorical and 2 quantitative, so answer E. Number 2, the bar graph below summarizes the response of dog owners to the question, where in the car do you let your dog ride? And then which of the following statement is false? So if you look at the frequency table on the right hand side, so most frequent is back seat, and least frequent is the driver's lap. And then they have a different also category there. Now let's look at it. So and then which one is a false? A, some owners let their pets ride in more than one place. Well, could it be, but we don't know. A majority owners, usually majority means more than 50%. Okay, so majority of owner allow their pets to ride in front of in the front. So in the front, right here. Okay, so there is more than 50%. So that's you can say, so that's true also. The most common place a dogs ride in the back seat. Yes, that's true. Like around like 68%. Now the vertical, so those are out. The vertical scale of the graph exaggerates the difference between percentage who let their dogs ride in the driver's lap versus the passenger's lap. So if you look at their driver's lap and passenger's lap right here, why they say the difference is exaggerate, right? Exaggerate the difference. That's true. Looks like a huge difference if you look at this, but actually this is a misleading graph, right? Why misleading graph? Because each dot, if you see that each dot here is a 10, but from here to here is very short, and then it start from like 0, so this is not actually 20, so that's what we call misleading graph. Okay, so that's a bad scale, so misleading graph. So that's the exaggerate. Yeah, that's true. So we are looking for something false, so it's out. Answer is E. These data could represent in a pie chart, which is not true. That's a false, because pie chart, usually that different categories, whatever that is, add up to 100% entire circle. But this is like 68%, like around like 55%, already over 100%. So that's not a good representation in a pie chart. Okay, so answer is E. Now let's move on, number 3. Here are the ages of randomly selected people at a community playground. So you have those numbers there. To make a stem plot of these scores, you would use as a stems. So this is stem and leaf plot. So question is which one is a stem? So let's say stem and leaf. So like 3 is basically 0, 3. And here the next one is a 5, so 0, 5. you don't put any comma or anything, so you just write right next to it, like 8 like that. Oh, there's a one more 3. Oh, there's a 4. Okay, I messed up this table, but you can redo here. So 3, 3, 4, and then also like 5, 6. I don't think they have a 7, so 8, things like that. I'm not gonna do every single one. Now, if you look at the tens range, so 10, 0, and next one is 12, and another tens. Okay, so 15. Now 20, I see that 21, 25, right? And then there's a skip. There's a no 30, but there's a 42. Things like that. It looks like that is outlier. Now, so this one, stems. Those are we call stems. Okay, these are leaves. So stems, as you see, 0, 1, 2. Hold on, there's a 30 something. No, there's a no 30 something. So should it be then answer? Hold on, 30. Oh. So you can use a 30 something. I think the answer is a C here. Because you have to have a stems like 0, 1, 2, 4. So those are not answered, right? That is not either. But as you see, there's a no 30 something. But you can use a 30, but there's no data. So it will be, this one should be answer. So 0, 1, 2, 3, 4. It's up to 4. Okay. Number 4. Now, if a distribution is a symmetrical, which of the following is true? Okay. So if you draw the bell curve, and it's a symmetrical means it's right in the middle. So this is a perfectly normalized curve, bell curve. So then which one is true? So if it's a perfectly normalized bell curve, then your median and mean, they're same. Okay? If it's exactly symmetrical, then they're same. So you have to choose, must be, they're equal, right? So number 4 should be B. Okay. Number 5, if a distribution is skewed to the right, so like that, right? To the right. Okay. You ski to the right, basically. So it's like that. And then you have to know that then your median somewhere here, but your mean is way bigger. The reason why it looks like there's some like outlier. Outlier is way bigger than like the other data. So your mean will affect a lot more than median. So it should be to the right, like that. So then which one is true? Then mean should be bigger, greater than median. Okay. Now number 6 is opposite situations. This one's skewed to the left. So it's like that. Right. So then opposite situation. So let's say this one is a median here. Your mean should be a lot smaller because of some like outlier here, right? So then your mean must be smaller, must be less than the median. So A will be answer due to the same reason, right? Now let's move on. Number 7. So this is only for multiple choice. And then I'm gonna upload another video for free response for chapter 1. Okay. Number 7. Now, next one. So Mr. William asked the 26 seniors in his statistics class how many AP courses they had taken during the high school. And below is the dot plot summarizing the result survey. Okay, and then which of the following box plot is correct representation of the same distribution? Okay, so if you look here, so let's see. Total you have 26 seniors. Okay, 26 seniors. So now, so 13th one and the 14th one, you have a right in the middle. So even number of data, so median is you take average of 13th one and 14th one. So if you count it, how many data here? So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, that means what? 13, 14 are located 3. So your median should be 3. Okay, so A, B is out because they're median and it's not there. Hold on. Oh, there's no median. So maybe median is overlap here or here. So let's keep it this one. Okay. So D, E is out. Right? So median is a 3. So only B and C possibly. So possibly that median. So let's see. Now, what is the first quartile? Then your first quartile is basically you have a 13 data. So let me summarize. So your minimum. So let's say 5. Let's do 5 number theory, right? Quartile 1 and median and into quartile 3 and maximum. Okay. So let's find out all things. Then you can find out which one is correct. So this is 1. Maximum is a 6. And median we just found out 3. And then, so you have a 13th data each side. So you see that 13th data and the other also 13th data. So 7th one, okay? 7th one is first quartile. So let's see, 7th one. 1, 2, 3, 4, 5, 6, 7. 7 is a 3. That's why we couldn't see another line. So 7 is right here. Another one, right? So that's not 7. So that's a 7th one is a 3. So first quartile was a 3. Now, 7th one from the largest one, 1, 2, 3, 4, 5, 6, 7. So your third quartile is a 5. Okay? So those are values. So since the median and quartile 1 is the same, the answer should be this. Okay? So this one is overlapped. So this 3 is also first quartile and also at the same time median. So answer is B. Okay. Number 8, survey was designed to study how business operations vary according to their size. Companies were classified as small, medium, large, and questionnaires were sent to 200 random selected businesses of each size. So 200 each one like that. Since not all the questionnaires in a survey are returned, the researcher decided to investigate the relationship between response rate and the size of the business. The data is shown below. Okay, looks like you see that here, different size of business, and looks like responded small business is the most, large business is least. Okay, let's see now. Which of the following conclusions seem to be supported by the data? So if you see that, look at B here. So small companies appear to have a higher response rate than the medium and big. Yeah, that's true, right? Because that 125 out of 200, that's a lot bigger than the other medium and large. So that is supported by the data. Okay. If you look at the other one, there are more small companies than large companies in the survey. No, that's not true because all 200. And exactly the same number of companies responded as didn't respond. So when you add this whole thing, same as this sum, no response is a lot more. So that's not true. And small companies dislike larger companies. That's irrelevant information. Now, if we combine the medium and large companies, then the response rate would be equal to that of small company. So what is the response rate for small company? So that's 125 out of 200. And then if you combine medium and large, so 81 plus 40, which is 121 out of but 400. So I don't think they are equal. So they're also out. So answer is B. Number 9, a small school has 10 employees. and then one of whom is a principal and the other are teachers. Suppose the principal makes 100,000 per year, and the other employees make between 40,000 and 50,000 per year. One day, the principal wins award, is given 20,000 raise. Okay, so only principal wins award and then 20,000 raise. And then which of the following describes how the school's mean and median salaries would change? Okay, so the rest of data stays same, but only the highest number, how highest salary is the principal in here, and then also that principal raise 20,000, so even further away. So it looks like that is outlier. Now, mean and median would both increase. That's not true. Mean would increase, and median would not change. That's what you have to say. So median increase, no. And let's see. So it looks like either B or C. So mean would increase, median would not increase, right? Because only the highest one is increased, and median not gonna change it. Now, mean increased, but how much? One is a, so okay, raise this one. So how many people there? 10 people, right? So 2,000, no, 20,000, right? 20,000 raise, but so how much it increase by mean? So 10 people, right? So that means 2,000. So the mean wise, 2,000 will increase, right? So then should be C. Okay, because mean is that total raise, which is 20,000 only for the principal, but out of 10 people, so 2,000 will increase for the mean. Now let's move on to number 10. The mean salary of the female workers is 35,000. The mean salary for all male workers, 41. What must be true about the mean salary for all workers? So now you can do. But what's missing here? We don't know how many workers for female, how many workers for the male. So to find out the mean salary for all workers, I need to have a number of workers each gender, but that's missing. But I do know, doesn't matter how many, but it should be somewhere between here, right? 35,000 and 41,000. So you can say it could be any number between that one and that one, right? It cannot be less than 35,000 or over 41,000, right? Because you're gonna combine it, so it should be somewhere between. So C is answer. And then you can say we don't have enough information to any conclusion. I mean, this is a true, so you can conclude that one. Okay, but you cannot conclude exact mean salary of all workers because number is not missing. Number of workers not missing. Number of workers is not given. Now 11, the mean mercury concentration in sample cans of tuna, 0.285 ppm. Okay, with a standard deviation of 0.300 ppm. Now, which of the following are correct interpretation of the standard deviation? Okay. So if you see, then best answer is E. The distance between ppm of mercury in each can and the mean ppm is about 0.3 ppm. That's what standard deviation is. Standard deviation is like average difference, right, in the data. How much away from the mean. Okay, so average difference away from the mean, that's the standard deviation. So if you think about that concept, E makes sense, right? The distance between ppm of the mercury each can, that's kind of average distance, and the mean, right? So average those from the mean, so that's a 0.3 ppm. So that's what exactly standard deviation is. Now, next on number 12, Mrs. Settle took a sample of scores, statistics partner quiz. So 5 number theory, we know that what is a 5 number, right? So this one is a minimum, first quartile, median, and next one is a third quartile, and this one max. Okay, those are 5-number theory. Summary. Now, about what percent of scores between 0 and 7? So, if you think about it, I like to draw box plot. So, this is a minimum and first quartile, median, third quartile, and max. And then all 25% data located. Okay, I want to memorize. So they ask you between 0 and 7. So between minimum and 7, so 25% data located. Okay, that's how you're gonna say it. Now use for problem 13 through 14 for that stem and leaf plot. 40 students, okay, that's here, number of students, took stat exam having maximum of the 50 points, okay? And then the score distribution is given. So this 2A means 0, 2 and 0, 0, 8 means 2, 8. And the other one, this is how you read it, 12, 12, 14, 15 data, like that, okay? I want you to understand how to read the stem and leaf plot. Number 13, Josh got the lowest score. Lowest score, what was his score? So 2, right? 0 to is 2. Now, interquartile range for the distribution of the exam score is what? Okay, so you have a 40. Okay, so then 20, 20 here, right? So there's a median. So interquartile range is a middle number and the middle number here. So so out of 20, 10 and 11 so on. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 and 11 right here. So both 3. Okay. So that means 23 is a first quartile. Now third quartile is 11th one, right? 11th and 12th one from the biggest one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 and 11. So that's a 4, 4. So that means third quartile is a 44. So interquartile range, right? Interquartile range means a third quartile minus a first quartile, which is a 44 minus 23, which is 21. So D will be your final answer. Okay, you're just checking you understand how to find out that data exactly, first quartile and median and third quartile. Number 15, the mean of the 4 people, 30. Okay, a new person whose age is 55 years old enters the room. The mean age of the 5 people is now what? Okay, so 4 times 30. Oops, 4 means 4 times 30 plus new person's age is 55. Now divided by total number of people is 5, right? And then that's the new average. So let's compute. Then 120 plus 55, 175 divided by 5, you get 35. That's a new age, new average age, right? So 35. Number 16, the 5-number summary for time spent on the internet each day. So that is, you know what that is. So those 5 numbers, we already talked about it. 300 students participated in a survey, and about how many people spent between median and third quartile. So 25%, right? Here 25%, 25%, 25%, 25%. So 0.25 of 300, that is how many people spend between 46.5 and 77 minutes. So 0.25 times 300. So you get like 75 people is in that region. Okay, so we can move on now. Okay, so that's a multiple choice, and then on the next video I'm gonna talk about free response.